G'day guys, welcome back to another video. So we are continuing on with our vector work and sort of keeping to build that block of vector knowledge and concepts and tying them all together. So today we're actually going to look at one of the trickier sort of concepts within vector work at this level. So we're actually going to start looking at vector projection. Now I've got this vector here, -2, 3, all right? That is my vector components. So if I'm shining a light towards the y-axis, okay, so this is what my orange lines are, then the vector actually projects this shadow vector of the vertical component, which is 3j. Now, I can also shine that light towards the x-axis, and I'll get a projected vector of the horizontal component, which is -2i. It should be a -2i, okay, because we're going to the left. All right, so we're getting that sort of projection of a shadow. It's almost like when we're out in the sun, you see our shadow on the floor. That's exactly the kind of thing that is going on here. So the projection of vector A on vector B is the component of vector A, which is in the direction of vector B. So we do have a little formula. So the projection vector of A on B is modulus A times by the cosine of theta times by vector B on the magnitude of B, which is actually a unit vector of B. So hopefully you remember from the last video, cosine theta is actually vector A dot vector B over magnitude A magnitude B. All right, so that's from our angle between two vectors. So we can actually substitute this into here. So we've got a modulus A over a modulus A, they cancel out. Magnitude of B times the magnitude of B is magnitude B squared, A dot B, and then we're left with a B. So that is how we get our result here. Now, this one is a whole lot easier to use than this one, especially because we're often not given the angle theta inside of our vector sort of triangle that we've created there. So this one here is super useful to use because we don't need that angle. As an example, so we're going to find the projection of vector A on B for A equals 2, 3, and vector B equals -1, 2. So substituting into this formula here, we've got A dot B, so the two horizontal components multiplied together, added to the vertical components added together. Now, the modulus of a vector squared, the square root and the square cancel out, and we're just left with the horizontal component squared adding to the vertical component squared, and then we're multiplying by our vector B, -1 and 2. So the dot product or the scalar product gives us a scalar. The magnitude gives us a scalar. Because we've got a scalar divided by a scalar, we're left with a scalar at the front. Now we have a scalar multiplied by a vector, which is just a simple scalar multiplication question. So all we're doing is multiplying 4 and 5 by -1 and 2. So we've got -4 and 5 and 8 on 5. And that is the projection vector of A onto B. All right. Hopefully this example helps. We have two different equations that we can use. This one is definitely a lot easier and one you'll probably use more often, but make sure you are all over using this one here as well. Hopefully this helps a bit, guys. Probably going to take a little while to get used to the whole idea of a projection vector, and that is more than okay. And we'll see you guys in the next video.